Welcome to this webinar or lecture on the topic of engineer-driven innovation and modern software development. And just to frame today's talk and to define the target audience a little bit, this will be a recorded webinar intended for the fifth-year students of the master's program in computer science and software engineering at Blekinge Institute of Technology. My name is Carl Fagerlund, and I have been working in the IT industry since 2001-ish, starting with a focus on systems administration and very heavy emphasis on IT infrastructure. Think big, fat, noisy servers, refrigerator-sized storage arrays, corporate networks, and of course, the absolutely dreaded desktop client management stuff. In 2007, I hit the pause on my career to get a master's degree in computer science from LTH, where I graduated in 2014. But I started working again in 2013. And for a while, I was working as a consultant. And pretty much since then, I have almost exclusively been working with cloud in some capacity. It's been primarily with the Amazon Web Services platform, or AWS, as a cloud architect. I've helped build e-commerce platforms, generating billions of euros in revenue. I provided input to global reaching corporate cloud strategies. I helped define backend supporting products finding their way into people's homes all over the world. But as cool as all those things are, when you're working with cloud, you're usually part of a team where you're very close to some really, really smart people working as developers. And it can feel a bit frustrating to look at these incredibly talented people building all these amazing things, and you deeply feel that you could do that too. So a few years ago, I pivoted again, and I have since become more or less a full-time software engineer, but with one foot solidly planted in cloud architecture. Which brings us to today. I am currently working at IKEA of Sweden, being part of a group called HomeSmart. And as a member of that team, we are responsible for the cloud backend of IKEA's current generation smart home product, Dirigera. At HomeSmart, I'm chiefly working as a software engineer and a cloud architect, which basically means that I'm responsible for defining how we best utilize our cloud services in both a performant and cost-efficient way. But I'm also extremely lucky to be part of an incredibly forward-thinking part of IKEA, where it really, really feels like we're carving out new areas of the market with our products, our services, and we innovate every single day. The things I will talk about today will be directly grounded in the ways of working and my own experience that we have at HomeSmart, and how we try to build a culture in our teams that dare to innovate and test new crazy ideas at an insane pace. That being said, I want to have a huge disclaimer that I am not here as a representative of IKEA today. And just to manage expectations, I will not talk about our product or the internals of the company. There is a lot to be said about IKEA, but not from me. IKEA is an absolutely amazing place to work for in so many ways. And I'm so grateful that I'm able not only to be part of this team and this organization that puts innovation front and center, but of course, also it gives me a great opportunity and privilege to speak to you guys and share our experiences. So that said, let's dive in. Let's start with this classic business mantra of innovate or die. It basically encapsulates the idea that companies must continuously evolve and adapt in order to stay relevant. And I would dare say that no company in the world is immune to this. And I would argue that most companies struggle with innovating. And history is full of examples of companies that fail to innovate and to stay relevant. So some really famous examples are Nokia. They failed to innovate and adapt to the advent of smartphones. They basically used to be the biggest cell phone manufacturer in the world. And these days, lots of people don't even know that Nokia still actually manufactures smartphones. MySpace used to be one of the go-to old classic social media sites. Basically, nobody uses them anymore because they fail to adapt and present meaningful and engaging features compared to their biggest competitor, which is Facebook. When I started to use computers, everyone and the internet, everyone used to use Yahoo. They had tons of different services for different parts of digital life, but they've failed to pivot from being a portal to be a real search engine, and basically were marginalized by the introduction of Google. But similarly, there's also a lot of notable cases where big organizations manage to innovate and they manage to stay relevant. So most people are already familiar with the massive FAANG companies, so Facebook, Amazon, uh, Netflix, Google, and so forth, and they know those stories and how they managed to innovate or completely pivot basically from the brink of collapse. Like, for example, Apple, they were basically bankrupt by the time Steve Jobs came back and streamlined a bunch of stuff, brought his experience from Next, and started changing the color of the Macintosh and to bring mass appeal, and then a bunch of other stuff. But some lesser known stories of huge companies that most people are aware of today managed to pivot and innovating by becoming leaders in the respective space in a completely different way. So, for example, Twitter, or as it's called these days, X, actually started as a podcast platform called Odeo. But when Apple launched its podcast platform, Odeo was in big trouble, and the team held a hackathon, and Twitter was actually born as a side project. These days, most people haven't even heard of Odeo, and Twitter is only basically famous as a social media platform. Shopify, not so huge in Sweden, but globally, it's one of the biggest platforms for creating online stores. And it initially started itself as an online store called Snow Devil, selling snowboards. But the founders were unsatisfied with existing e-commerce solutions and decided to build their own. And eventually they realized that the potential for growth, offering a platform for e-commerce, had a lot more potential. So they pivoted into creating a platform instead that allows anyone to set up an online store and taking care of the difficult stuff like payments, registration, user management, etc. I don't know how many of you guys have heard or used Slack, but it's extremely popular in the corporate space for communication. It's used and loved by small and big organizations alike, and it's a super powerful tool for communication and collaboration. I would say that Slack vastly outperforms its main competitor, Microsoft Teams, in terms of user experience and ease of use. But it actually originated from a failed online game called TinySpec. The chat tool that they developed for internal communication was basically the only thing that people liked. So the company fully leaned into what people loved and turned it into Slack. If any of you guys are nerds enough to know about IRC, I think you'll share my bitterness in the sentiment that Slack is just a bit pretty looking IRC clone, but I digress. So clearly, looking from a commercial perspective, innovation is an absolute must for any company that is not just looking to succeed, but also live for a long time. So how does that relate to the engineers at said companies, and how do their innovations help companies to innovate? So let's scope what we actually mean by innovation and go from macro to micro. So obviously there's the textbook definition, which basically states that it's an implementation of ideas resulting in introduction or improvement of goods or services. And there is even an ISO definition somewhere, but I'm not going to bother to recite it here because it's very long and very boring. But I would claim that the biggest misconception is that innovation has to be this brand new idea, something that the world has never seen before. And that is absolutely not the case. It can mean something as simple as doing something slightly differently, refining something that is already available, making services more accessible or relevant to meet new or changing needs. So no one who actually knows anything about technology history would claim that Apple was the first to invent the technology that neatly packaged everything into the iPhone. But conversely, most people would not contest that the innovation brought to the market by the iPhone has been one of the most significant drivers of change in how we perceive and use tech on a daily basis. I would say that it probably catapulted the view of smartphones from being seen as this business device into a desirable consumer product coupled with an integrated software platform. And just to touch on the relevance of the App Store, when it was introduced in 2008, the closest thing you could find was a game client called Steam, which targeted gamers. And this is still around today. But all of a sudden, the general population had an intuitive and easy way to not just buy, but also to install software that you could trust because it had been pre approved and verified by Apple not to be malicious. It had to meet certain quality requirements. And it basically changed how the general population viewed software and what kind of services and utility they could provide. And this was a refinement of existing ideas that the world had seen before, but yet Apple are considered the biggest innovators in this context. And we like to think about these huge disruptive companies, but for the vast majority of cases, innovation is rarely a top down affair. So, what I mean by that, it's not Steve Jobs coming into the room and saying, I want my music on that thing, get on it. That's not really how it works, but rather it's the result of a conscious effort, or in the best case, from passionate and engaged people who really care about what they do. So for large organizations, that means having a really close collaboration with people doing the actual work or trusting them enough to let them try new ideas. The vast majority of cases, and most innovations are, when observed in a vacuum, absolutely tiny. From a consumer perspective, it can mean having a new button that saves you a click. And if you don't think that's significant, try telling that to the people that had to suffer the start screen on Windows 8. But from an engineer perspective, day-to-day innovation in your job can be something as simple as recognizing that a step can be skipped in a process, automating a thing that saves 10 seconds but runs 10 times a day. It can be adding some kind of alert to be able to act faster on errors, or introducing a tool which makes your code easier to maintain. But the main big key takeaway here is that innovation is typically iterative and almost never a big bang. And sometimes it can really feel like things come out of nowhere and suddenly it's on everyone's mind. So, for example, the internet, smartphone, electric cars, and generative AI, like, did you guys ever feel like, where did OpenAI come from? All of a sudden, it's just here and everyone is using generative AI. And that's amazing. But these technologies were the direct result of thousands upon thousands of engineers doing incremental, iterative innovations that build on another to finally present something that seems absolutely huge and is bound to change the world. And today, I'm going to argue that the silent catalyst for all of this, and that such innovation is able to grow best in organizations, is where there's a high degree of trust, because it brings autonomy and agency to engineer teams and encourages them to take ownership of the things they are building, own their mistakes, and of course, encourages innovation. So let's take a step back and start to define what innovation is in a friendly environment. And I would say it begins with trust as a foundation. So trust brings creativity, psychological safety, ownership, and accountability. So let's try to expand on that. So engineers who trust their contributions are valued, regardless of the outcome, don't necessarily need to feel pressure about performing to absolute perfection. We know that perfection is the enemy of good. So instead of pursuing perfection, we trust in the mantra of good enough. So in an atmosphere of trust, failure is seen as a learning opportunity and not as a career setback. So trust is a two-way street. So when the organization trusts its engineers, the engineers in turn will trust the organization and take ownership of the things that they build. Trust brings transparency, and we feel safe knowing that we will not be blamed personally for things that go wrong. So instead, we are trusted to fix the mistakes and learn from them. IKEA's founder, he said a lot of cliche things, but some of them are not so bad. And Ingvar Kamprad, said, only those who sleep make no mistakes. And if we accept that statement at face value, why not just make the best of it? Because there are so many things to learn from things that go wrong. And in many ways, it's probably the most brutally honest kind of feedback you can get. Knowing that I'm responsible for fixing my own mistakes is an incredibly strong motivator to not deliver half-assed things. You can bet your last dollar that I will go to incredible lengths to make sure that I'm not going to get a phone call in the middle of a Tuesday night because some service failed on the other side of the planet, and whoever decided to make that phone call seems to think that I'm the only one who can fix it. And trust me, it has happened. But on the flip side, I can also speak from experience and say that the ownership is really empowering. It's very encouraging, not just from a responsibility perspective on my own end and from my own task, but for my entire team and our contribution. When we own it, we also want to make it better, faster, stronger. And with that ownership, there comes a sort of impact and real responsibility. One of the funniest guys in IT, at least if you're a cloud nerd, is Corey Quinn. And he's a cloud economist and he writes way too much stuff on different types of social media. But he said something that really resonated with me, where he summed up the amount of trust required to have real impact in large organizations or small ones for that matter. And basically, he said that if you went into Google as a site reliability engineer, he doesn't think it's possible to bring down google.com even for an hour. And if you don't have that sort of agency, what kind of impact would you have? Even if you went in maliciously and intentionally, how much upside good are you actually able to create in a place like that? If you compare that to a small business, and it's like, if you screw this up bad enough, we don't basically have a company anymore. And I can tell you, it's not that I'm not out to screw things up, but knowing that I'm able to have that sort of impact, which I do at HomeSmart, materially changes basically how we innovate and how we take ownership of the things that we build. Now I want to talk about something called DevOps. In traditional IT structures today, there are clearly defined responsibilities for developers and operations. Developers are responsible for basically producing code and making something that will have value for their customers. Operations, on the other hand, define a standard which everyone must follow. And this can be menial things like operating system of the coworker laptops or the choice of cell phones, but also underpinning in absolutely critical pieces of infrastructure like server hardware, supported runtimes for programming languages, corporate firewalls, et cetera, et cetera. The problem is that this division will inevitably create some kind of friction because the developers and operations have fundamentally different goals. One party is supposed to keep everything working, keep the lights on, basically. And you all heard of this, if it's not broken, don't fix it. Basically meaning they have a very, very strong incentive to resist change. The developers, on the other hand, literally has it in their job description to introduce change. And they will most likely also find that the defined standards do not always meet their requirements. It could be that they need a new tool that isn't supported by operations. They need to upgrade their runtime because there's a critical security patch or something like this. But when operations isn't able to actually meet those requirements, what actually quite often happens is that developers just take their stuff and they throw it over this wall. It lands in the lap of operations. They don't really know what to do with it. Things start to break. Everyone blames everyone. And basically you create a chaos and this contentious kind of push and pull between developers and operations. But if the organization instead trusts that the developers know how to meet their own requirements and empower them really magical things can happen. So despite the best efforts of really large consultancies with some cool 3-letter abbreviation, you cannot buy DevOps because DevOps is about culture. If you're deploying servers and you're not shipping code, you're not DevOps. It's like saying you're doing vegan because you bought an Impossible Burger for lunch while still having a full English breakfast the next day. And conversely, if you're a developer and you refuse to share the responsibility for your team's pipeline, you're not DevOps. It's like saying you're a team player, but you refuse to pass the ball in a game. So it's not a tool or a one-off task. It's a culture of collaboration and shared responsibility. Teams with ingrained DevOps culture are typically highly autonomous with a high degree of agency. And you move away from the responsibility of just delivering components and building blocks, and instead you take responsibility for your own service and your own situation. DevOps leans heavily into trust of the teams to build whatever they need to deliver the desired results. And again, you can't buy DevOps, you can't buy trust, but you can earn it and you can give it. So in large organizations with entrenched culture of process and waterfall, it can be extremely difficult to earn. And it all starts with the hiring process. People will work inside their given mandate, but if the responsibility and role is too clearly defined, you will also end up hiring people who are very comfortable with that type of division. Conversely, if your job description and organizational culture instead explicitly state that the mission is to solve problems and get it done, it serves as a magnet for individuals who thrive on challenges and innovative thinking. Because this targeted approach to hiring is not just a checklist, but a declaration of the kind of workplace environment you're creating. And it's one that values proactive problem solving and hands-on execution. And such an atmosphere is incredibly appealing to engineers who relish the ideas of empowerment and ownership. These are the very people most likely to drive innovation within your teams. So in essence, fostering a culture of trust is not just about keeping talent, but it's also an compelling invitation that attracts innovative minds to collaborate, create, contribute to reaching your goals. So basically what I'm saying is that trust invites innovative people to come work with you. As an engineer, we live to solve technical problems. And we love doing that by applying logic and technology, and also, of course, a healthy dose of elbow grease. But you should be familiar with this feeling if you made it this far into your master's degree program, the sense of accomplishment when the thing that you built not just runs, but it actually runs and produces the expected result. And this amazing feeling like, wow, this is so cool. I can't wait to iterate on it, add some more features. And you really want to put this unmistakable personal touch that says, I solved this problem on it. And there's a pride in a lot of engineers to know the most, reach the solution the fastest, make the most elegant solution, or use esoteric programming language to solve things differently just because they can, just for the joy of solving problems. If you ever doubted how much engineers love solving problems, all you have to do is check the advent of code subreddit to get a tiny glimpse of how people innovate to solve problems differently than everybody else just because they can. Which really leads us to the next point, and that is that organizations where engineers are allowed to thrive, they harness this creativity for innovation. And this isn't something that I made up. It's a studied phenomenon that is heavily supported by literature and academic papers. And it's been studying the effects of empowered teams and the effect of trust and what the measurable quality that is being output from these innovative companies and how these companies are able basically to use that to their advantage. One of the most famous studies was something called Project Aristotle, and it was done by Google. So let's talk about Google just a little bit. Google has fallen quite a bit from grace since the change in leadership a few years back, but it's undeniable that when the Project Aristotle was being conducted in 2012, Google was one of, if not the most desirable big tech company to work for in the world. To get a chance to work for Google in 2013 when I graduated was a dream. For me, it was a pipe dream, but whatever. The aim of the study was to identify the factors that contribute to team effectiveness, especially within the context of Google's own work environment. By examining various aspects of teamwork and collaboration, Google hoped to gain insights into what makes some teams more successful than others. And the study analyzed data from 180 teams within the company and concluded basically, based on hundreds upon hundreds of interviews and surveys, that the key finding are things that we have already touched upon. But the most critical one is the concept of psychological safety. So what that means is that you have a strong feeling of freedom to experiment, that the engineers, they feel psychologically safe, that they are more willing to take risks, try new approaches, and innovate without the fear of repercussions. In psychologically safe environments, team members from various backgrounds feel that they're free to share their perspective and create a breeding ground for innovative solutions that may not arise from a homogenous group. And what I mean by that is not just simply different areas of tech, but also from gender and ethnicity. And this is what they call openness to interdisciplinary ideas. Furthermore, a sense of safety allows team members to openly discuss their challenges, but also collaboratively arrive at solutions, basically using collaborative, collective intelligence and varied skill as a team to reach solutions. And this is the whole aspect of collaborative problem solving. There's also a strong sense of being able to fail fast, but learn faster. So psychological safety enables a culture where failure is not stigmatized, but rather seen as a natural part of the innovation process, leading to quicker learning and quicker iteration. And lastly, open dialogue, where psychological safety encourages honest feedback, essentially for quickly identifying problems, validating new ideas, and moving projects forward without feeling that you have to take bias into account or things like not coming from the right place, because everyone knows that we are just trying to get to the goal as soon as possible. Since 2012, Google has been involved in a lot of controversy. We can observe how the change in leadership has had a profound effect on psychological safety. And it used to be a company that focused on innovation and brought things that changed how we perceive search, how we navigate in the physical world, interact with our cars, and what we expect from free services. But in the last few years, the news have rather revolved around layoffs, highly public firings of high-profile researchers, killing of entire products and teams, to the extent that there's even a famous website now called the Google Graveyard. And Google is not seen as the forerunner for innovation anymore that it once was. We can see similar effects at other companies that are also famous for its innovation, for example, Tesla. And I'm not going to discuss more about what has actually changed, but the change is there. And it started with a leadership that changed a culture of feeling safe for its employees and focused more on profits. Okay, so let's move on from that. Now that we have trust, now we need to start thinking like scientists, because in order to innovate, we need to have the conditions for experimentation that is repeatable and verifiable. A core tenet of everything we do is automation. And if we're doing repeated work and it can be automated, it probably should be automated. Some tasks are inherently difficult to automate, like user interfaces and things that require manual intervention, reliance on physical hardware, etc., pressing a button or reading something aloud or whatever it is. But we should have at least a prerequisite is that the things that we work with, they should have an API. If there's no API, it will become very difficult to automate. Say for programming, like an industrial robot to carry out the actual work, but for most teams, that's probably not an option. But even if we do have an API, we also need to identify when it's not suitable to automate. So you can feel free to reference this XKCD comic regarding the amount of time that you save to make a judgment call whether or not you think it's worthwhile to automate. But this also brings me to platforms. It's a nebulous term, which in our context usually refers to giant product suites of some sort of managed service. And typically something would be like a cloud provider, like Amazon Web Services or Microsoft Azure. But it could also be something new, like OpenAI, or something completely different, like Google Workspace. Um, the common denominator is that we can treat all of them as a utility. And I will talk more about what it means to treat something like a utility in just a sec. But another common denominator for all of these platforms is that they are API driven, which means that suddenly we have the means to produce something called infrastructure as code. It's a huge concept of its own. But the TLDR is that we can, with scripts, tools like Terraform, Azure Biceps, AWS CDK, or whatever may tickle your fancy, you have a way to define your infrastructure and what it looks like with automatable, repeatable, deployable code, which is part of our development and consequently our innovation. So platforms are these incredibly powerful tools that we leverage to create value. But don't make the mistake of thinking that the platform you're consuming is the creator of value. Rather, it's a value contributor. So think of it like having a solid everyday utility, and we're talking about roads, water, and electricity. So not the Swedish railway system. And you don't really expect to create value from those utilities, or you don't expect that the value is in that utility, but rather from the goods and the services that you produce using those utilities. And that's the last part of connecting the dots to scientific method. We must also have observability. What is the outcome of our experimentation? Observability encourages transparency. It holds us accountable to our outcomes, and it further promotes trust. Did it improve efficiency, our lead time, user satisfaction, cost efficiency, whatever? So again, leveraging the existing technologies to build on already present in the platforms and the technologies that we use. Every programming language has the ability to generate logs, and every platform has the ability to generate alarms. So, but most important of all, everyone loves a fancy dashboards, and especially managers. So just to drive home the value of consuming a utility, a key point about what we have talked about so far is that we need certain conditions to create a foundation of innovative engineering organizations. But so far, what we have talked about can be considered infrastructure, or again, utilities. So why does this help us create value and stay innovative? And I'd like to explain that further by using an analogy of custom cars versus delivery trucks. So let's say that you are a huge car guy, or car girl for that matter, and you buy a car. And we call this car Lizzie, because I don't know, maybe it's a Lexi, maybe it's a Lexus. And we really love Lexus. We really love Lexus. We take care of the car, we polish it, and we drive it, and it's a joy to drive. But eventually, cars need service. And when they do, we take them to the car service. And the car guy might look at it, yeah, you have a chip on your paint, let's patch that up. But eventually things break down more, and the more custom your car is, the more exotic it is, the more stuff you're going to discover after a while. It just breaks down, it becomes very expensive. And eventually you start thinking about, well, maybe I should replace this with another expensive car. So you buy Lizzie, and then all of a sudden the cycle repeats itself. But what if we are a delivery company? Our job is to have a bunch of vans, and with those vans, we deliver goods and services. These vans, they break down too. But if a van breaks down, it's very easy to replace it with an identical van that can fill exactly the same functionality. Obviously, you can still service, and you will service your delivery trucks, but after a while, it simply becomes more economical to send that delivery truck to the scrapyard and you replace it with an identical van. The good thing here is that if we see an increased demand, all we need to do is get additional vans. Likewise, if demand decreases, we can just get rid of the extra vans. So with custom cars, each and every one is special and unique. And while each car is a valuable commodity, there's definitely some joy in maintaining them. From a business perspective, it's hard to claim that they create the value. You spend a significant time and resources on your maintenance. When something goes wrong, you go to great lengths to fix it. But delivery trucks, our main primary concern is the value, the number of packages that we can deliver. The vans are interchangeable and easily replaceable. And some customization might be possible from the manufacturer, provided it's a standard equipment. But for the most part, it's going to be delivered as is. And we're fine with that. Because when one breaks down, we trust that they can be easily replaced with another one that fills exactly the same function. So while cars in themselves can carry incredible monetary value, they are not themselves the value add or the differentiator. For a business trying to bring a product to market, they are just the tool to create value. And this really highlights the importance of treating the previously mentioned platforms as a utility. It's the same reason we're not really interested in building our own highways when we're when we're a delivery company. We're probably not really interested in hosting our own critical infrastructure in individual teams just because we're building cool things and try to bring it to the world. It might be fun to build your own server, hosting your own Git, deploying a Kubernetes cluster, and run your own Jenkins infrastructure. But again, from a business perspective, that's usually not where the value comes from. Without endorsing any particular service, the plethora of hosted and managed services provided by AWS, Google, Microsoft, GitHub, GitLab, the list goes on. It is so incredibly simple, and it has never been easier to go from an idea to reality without having to worry about the nuances of operations. So again, platforms are these incredible, powerful tools that we use to create value. And no, it's not about endorsement. But yes, at a certain scale, you will run into a conversation whether or not it's more cost efficient to run your own rather than to buy a service. For example, Spotify famously have moved their stuff around. And I think it was King who make games for mobile, and Facebook decided to bring everything from the cloud back into their own data centers. But that's when we're talking about a very specific use case for a very, very large service. And that's really outside the scope for when discussing about innovation. When you're concerned about innovating, you don't want to waste cognitive load on thinking about if your run apt update recently on your Linux server, for example. So now that we have those things in place, the final piece of the puzzle with the scientific method is to test. And testing is arguably one of our biggest responsibilities to conduct regularly. It is so important that even it gets its own slide instead of being lumped together with automation, observability, and platforms. It does not only help us to prove our hypotheses, but it builds that oh so important trust that we really want. And I can't even begin to describe how many times testing has caught errors that would have been absolutely disastrous if they had been deployed to production. Testing should be an integral part in all pieces of your service. And it's not as simple as just writing a bunch of unit tests and call it a day. If you've done your homework and maybe you've even taken dedicated courses on the subject, you should be familiar with integration testing, system testing, end-to-end testing, and perhaps even chaos engineering. If you haven't heard of chaos engineering, I highly encourage you to look it up. Netflix basically created a novel way of testing, basically innovating in the testing space where they willfully introduce fault into live services. Look it up, it's super cool. But tests will help us prove our ability to recover from failure. It can be something as simple as catching exceptions in your code, but more likely it's about trying to build something robust that handles errors graciously. The CTO of AWS, Werner Vogels, he famously said, everything fails all the time. So if we expect things to fail all the time and we build mechanisms to handle that, nothing will fail. But that kind of robustness only comes from very, very careful testing. So the testing itself, especially in the higher levels of your service, not just the code, will decide your strategy for recovery. Are we talking about immediate rollback, blue-green deployments, circuit breaker patterns? The strategy of recovery will in turn decide how fast you can act on failures and how fast you can iterate. And trust me, things will break. They will break when you least expect it, and they will break in a spectacular fashion. But we embrace it and we own it and we learn from it. And because we have the psychological safety I was talking about before, we'll still sleep safe and sound at night, knowing that we will still have a job the next morning and the team will continue to iterate and fix things and build new innovative solutions. Testing is a huge area of expertise. And just like everything else in the trust equation, if you want to maintain that agency that makes it possible for you to innovate, you need to be comfortable with it. Not everyone needs to be an expert, and you don't even need to be passionate about testing to take it seriously, but you have to take it seriously. And if you want your team to stay autonomous, it's something that you have to share the responsibility for. This together ties up really neatly into a powerful feedback loop, which enables us to iterate and innovate very, very quickly. Maybe you have heard of the abbreviation CI/CD before, and it stands for continuous integration and continuous deployment. And it basically talks about all of these aspects that I have already talked about. If you like to code, maybe you're taken aback by this picture. The portion of coding is tiny in the proportion to all the other things. And while that's true, remember that we have been heavily leaning into automation. Most of these parts, except for the code, is automatable. CI/CD gives us an incredibly powerful foundation to lean back on. And when we want to make short iterations and evaluate as we go, this is the way to do it. If you choose to have only one takeaway from my talk, make it this picture. Okay, so awesome. Now we know how to iterate very quickly. And this is when we iterate and we innovate. And remember, innovation does not need to be a brand new idea. Sometimes it's just about doing something different and hopefully something better. That something could create value. It could be the code, it could be the process, it could be the automation, but it places emphasis on the value creators. That is the code, that is the process, that is the automation. The faster we can iterate, the faster we can make a judgment call whether or not our ideas bring value. And when you discover your theory doesn't pan out or you're not getting the expected results, if it doesn't bring value, discard it. There's going to be a lesson to be learned no matter what. And that in itself has incredible value because it helps us go forward. The fast iterations are only made possible by the safety net provided by the tools and the foundation we put in place. And this safety net encourages us to take risks because when we feel confident that we can recover from errors, the cost of failure is negligible compared to the value derived from the lessons we learn. The more effort and energy being spent on the more expensive it's going to be to fix. So by making small iterative changes, we introduce small mistakes, and these are cheap to fix with very little consequence. In my team, we have some incredibly skilled engineers, and some of the best ideas have started as very tiny prototypes or pilots that have been iterated upon. So when you have a sense of agency, you can quickly throw something together with those people that you can poke at, critique, and give feedback on. And sometimes it even ends up in the hands of customers for them to provide an opinion. Sometimes it can take hundreds of iterations before you arrive at something that you really like or you feel confident that you can actually put in production for general availability. But with an organization that promotes engineer innovation, it will reward testing these new ideas because they know that some of them will be great and bring value. I can't count how many lines of code that I've discarded, but likewise, I can't even begin to describe the ways it has made me a better engineer. It's definitely made me a better coder. You try different patterns, algorithms, sometimes even new languages to do things better. Testing new ideas means you get a chance to test new technologies. It can be something as mundane as testing, I don't know, generics in Go, but it can also be something huge, like measuring the performance impact of a brand new runtime like Bun and comparing it to Node.js. It has made me a better architect because it helps me iterate on ideas that I really need to clarify complex systems so that the rest of the team and everybody else can understand my ideas and how it fits as a part of the puzzle that we're building. When the expectation is that the team is going to share the potential burden of implementing and supporting the new ideas made real, you really have to learn to break down your ideas into piecemeal chunks that are understood by anyone. But no matter the outcome, there is value in the process and the discovery of prototyping, rapid, iterative, quickly improving on ideas. This brings us back to the innovative engineer. So if you remember what the topic of this talk was, basically, how do we encourage engineer-driven innovation? So let's talk about what it actually means to be an innovative engineer. But first, I want to try to explore a little bit what it means to be a good engineer. A good engineer is not just someone who writes good code. A good engineer is someone who is part of a community and understands the importance of building and being part of a community. And this cannot be overstated. Taken from my own experience, when I participate in AWS community events to see what others have built and are willing to share, more often than not, I go home with ideas of my own that I want to realize. And when other teams at HomeSmart share discoveries or new knowledge, I race to be the first to accept the meeting invite. When my colleagues want to show how they solved a bug, not just by patching it, but rather actively improving the code, and they have seen an opportunity for refactoring, I'm thankful that I'm put as a reviewer for their pull request. Some of the most successful things that I have personally built are the direct results of getting inspired and mentored by others. So the people who are the most generous with their time and knowledge are the best catalysts for these new ideas and innovation. And if you can be that catalyst for someone else and have a chance of your ideas being iterated on, be that person. Assume that you have a piece of a puzzle that other people's simply don't have and might be struggling to find. Something that comes with experience is recognizing solved problems. And I still struggle with this, but it is important to realize when things don't necessarily are already a solved problem, they don't necessarily need to be improved upon. Or it's a detractor from your goal to try to innovate on something else. Try to leverage the fact that the frameworks for front end are already extremely powerful. Use the fact that the cloud providers and the different services have solved infrastructure as code and made it automatable. Use them as appliances and utilities to help you reach your own goals faster. And in the same vein, you need to stay updated through these communities, through blogs, tech videos, conferences, just to know what's actually available. Our industry is absolutely insane when it comes to the fast pace of innovation and the stuff that becomes available. And you will never have a full picture of what's actually out there. There will be a lot of people who will try to sell you solutions to problems you didn't even know you had. But learning from your community and your peers, you'll discover that the solutions to those problems, maybe you'll discover them together, inviting faster iteration and new innovation. That said, one of the most important qualities of the innovative engineer, in my opinion, is to have no to little prestige. Don't get too married to your ideas, and instead lean into the ability of knowing when to toss your ego aside. Worst case, you learn something if your ideas don't pan out. Best case, another idea was born from yours and the iteration feedback loop is in full swing. So again, I can't count how many lines of code I've discarded. And sure, sometimes it can sting, but I can't, again, describe how this had made me so much of a better engineer. That said, a word of caution, don't get lost in building a Rube Goldberg machine of complexity. It's really easy to get up in the moment of building something awesome just to realize that you created a monster that no sane person will be able to understand or maintain. If you start seeing your colleagues starting to say WTF more often than usual, remember that we want to iterate on our ideas. Stuff that can't be maintained is very difficult to iterate on. Building stuff that is easy to maintain is a true art form. And there's a cliche saying something like, simplicity is the end result of long, hard work, not the starting point. And one could argue there's innovation in refactoring as well. So don't worry too much about it, but try not to get caught up building insane chains of complexity. To wrap things up a little bit, the visionary leaders that are celebrated in media for having creative genius and business chops are no doubt incredibly intelligent people, and the vast majority of them are also incredibly skilled engineers. But when you look at their individual contributions to bringing these products to the world, they're really standing on the shoulders of passionate engineers who basically just love solving complex problems and build cool stuff. These aren't people looking for, fame or magazine covers. They're the ones who get a kick out of finding an elegant solution to a problem that's been bugging everyone for ages. They enjoy the puzzle, the challenge, and the opportunity to build something useful or cool, or both. And the point is, innovation isn't a solo act. Rather, it's more of a team sport. And it's great that leaders get recognition, but it shouldn't overshadow the collective hard work that goes into making these visions a reality. These leaders are successful in large part because they work with talented engineers who love what they do and turn these ideas into something tangible and valuable. I would argue that one of the greatest skills a successful visionary can have is to empower the teams to innovate. And in the end, it's all a giant web of intertwined innovations, layers upon layers of ideas building on another. There's a couple of things I'd love for you to read. The Cathedral and the Bazaar is an essay by Eric S. Raymond that compares two different approaches to software development. The Cathedral model is a more traditional top-down way of building software, whereas small groups of people work in highly coordinated ways like architects and builders constructing grand cathedrals. This method is polished and planned, but it's also slower and requires a lot of oversight. But on the flip side, the Bazaar model is more like a lively marketplace. Imagine vendors shouting and trading goods, where everything is a bit chaotic, but it's also full of energy and creativity. And in this approach, the software is built collaboratively by larger, more decentralized groups of people. And the end result might be a little rough around the edges, but it's created much faster, and it's often much more innovative because so many people have had input. The Phoenix Project by Gene Kim is a novel that dives into the world of DevOps, and it basically tells a story of an IT manager named Bill who was put in charge of a project that's behind schedule and over budget and a big fat mess. As the story unfolds, Bill and his team, they start treating their work like a production line in a factory, and they identify bottlenecks, streamline processes, and iteratively work innovatively to solve these problems. And last, we also have The Lean Startup by Eric Ries, which presents a new framework for business development that draws from lean manufacturing concepts. I'm not going to talk too much about this book, but basically it talks a lot about making MVPs, minimal viable products, and putting them out there in the real world as quickly as possible, really cementing this idea of quick iterations with fail fast, learn faster. These three books and essays, they all draw from real world experience when it comes to fostering engineer-driven innovation, from a cycle much like the CI/CD feedback loop that I previously showed. So yeah, thank you so much for listening. And now I hope you guys go make something cool. I think I timed this pretty well. It says 10:58 here. So yeah. Now I was kind of hoping that there would be some questions and some panel discussion.
I think it was a very interesting lecture, and I really like how you bring up this with trust. And many of our leadership courses, we train on these group dynamics and all these things, but I think we tend to forget this talking about trust to share the joy of solving things, but also maybe share the mistakes we make and so forth. So that was very good that you emphasized that. I also have a question related to when you were a student. What was the things you missed in your education that you think you, looking back, you would have liked to have more of?
That's a really tough one. So usually, something that we also see, I both felt it, but we also see it when we get our junior engineers, is this notion of, I don't know what to do. While as the senior engineers will rather ask, what can I do? And they actively look for things to participate in and actively grab interesting tasks. When you're fresh out of college, you have all this book knowledge, and you discover very quickly that the world is much more dirty and not as academically perfect as you maybe think if you don't have any prior working experience. Ideally, if you have a good thesis work and the company where you conduct your thesis at is a good one, they will let you in basically on their ways of working, and it will bring you some perspective. But I remember distinctly, like, you end up in this group of people that had seemed to have been doing this forever, and you just don't know, like, where do I fit in? What can I do? And sometimes I wish that there was more of a celebration of mistakes, as it were. Like when you're in academia, failure can be debilitating. You fail your exams, you fail your thesis, and you feel setback. But I wish there was a way that encouraged people to make mistakes and learn from those mistakes that were not as debilitating, I suppose. Because when you get into the corporate world, you will discover that if you are in a high trust organization, it's not the end of the day if you make a mistake. And especially, I feel, in Swedish organizations, people are nice, generally speaking. And if you make a mistake, we'll fix it and we'll move forward, and we're going to iterate on it. If you're in a very high competitive academic environment, which like the civil engineer program sometimes can be, that celebration of failure can be really difficult to shake, like this dread of making mistakes. So yeah, I guess that's one of the things that I wish I had learned better. It took a long time to be okay with making mistakes and being open with them and sharing them and inviting people to learn from them.
That's an encouraging answers, especially if one has some exams left. It feels like it's a learning experience to do them again.
I suffer with you guys. I have some trauma still from my exam cramming.
Vill ni komma fram eller vill ni ställa frågor?
Ja.
Then we take the first student question here.
Sure.
Hi, Cor.
Hi. Hey, man.
Very interesting talk. Probably the best guest lecture so far.
Thanks.
So I had a question regarding the cloud architect aspect of your work. With now, I think it was Amazon Video Services that published a paper of sorts where they're moving from microarchitectures to more of a monolithics. Do you have any thoughts on that change that might, what I understand is going on in the industry? That
oh yeah, absolutely.
You go to creating these custom cars instead, if it's a fitting analogy.
Yeah, absolutely. So yeah, I have tons of thoughts about this. So if I remember correctly, it was a specific company that was basically streaming video, where they discovered that using a microservice architecture was very expensive and much slower, specifically for their use case. But to me, that just is a signal of a very healthy industry. So everyone in my community immediately recognizes, oh, awesome. They recognized that something wasn't working for them, and they decided to iterate on that and make something more that fitted them, basically. And there can absolutely be value in creating these bespoke architectures where you build these monoliths that you simply host on very powerful servers. There is absolutely value in that. Unfortunately, the media seem to have interpreted that as there's a shift in ideology where things are starting to move over to monoliths instead, that run on less managed services and instead run on these bespoke servers with beefy hardware where you run everything at the same instance. And that is 100% not the case. I celebrate the fact that they identified a defect essentially in their architecture, and they were able to make something better. And that's really what we're looking for when we are working with the cloud, because it helps us do things faster. So when you work with cloud, you pay for what you use. And the higher degree of managed service that you consume. So for example, if we're talking about microservices, we are usually talking about functions as a service. We're talking about something called serverless, where of course there's a server somewhere, but you don't see it. You just package your JavaScript bundle or your Python package or your Rust binary, and you basically put a tiny function of code into the cloud and run that. There is nothing else for you to worry about. That type of managed service is incredibly powerful. And I can tell you that at HomeSmart, basically 100% of our backend is serverless. We are responsible for the entirety of the core backend for cloud. And we're a team of 12 people that are not just responsible for developing the backend, but also running it. And that would be very difficult if we run it on bespoke hardware. But if you're looking at a company like this video streaming company, most likely they have a large group of engineers whose sole purpose is to manage those servers. And there can be value created from that if you discover that you actually save more money by doing that. Because at the end of the day, it's all about creating value for your customers, for your own company, and just try to reach profitability. So yeah, to sum it up, I think that the media portrayal of this shift was really unfortunate, and it does not reflect at all my experience, because good engineers will recognize what technology to use for their specific use case.
Okay.
Does that summarize it? Or
yeah, great answer. Thank you.
Cool.
Tar vi nästa fråga? Jättebra.
Hey Carl, I'm Albert, and like
What's
Adam, I have to agree that it was a great lecture.
Thank you.
Very interesting.
Thanks so much.
I was wondering a bit about if we go back to the whole trust thing. So have you had any experiences where maybe there was someone or like an entire team where there was either less trust or low trust within the team or from management, for example, or maybe there was a high degree of trust, maybe in the context of new developers joining the team as well?
Absolutely. 100%. So it's not uncommon that there is someone in the team who doesn't trust the process, he doesn't trust his colleagues. But like I also said, it's a two-way street. Most of these autonomous teams, they really love engineering, but it's also the cliche that it's a team sport. It's not a solo act. If you discover that you are not trusted with your ideas never get implemented, and nobody really listens to you, you most likely won't be very happy in that type of environment. Similarly, if you have a leadership that doesn't provide you with trust, that can completely alienate the teams and basically decimating the quality of their output. And as I was trying to make a point of before, the stuff that we see coming out of companies where that sort of trust shift had happened, like for example, Google, You have things that the engineers don't really believe in, like this new cookie thing that they're making, or you have this military AI thing, and a lot of people speak up, and basically the management says, we don't care, we're going to do this anyway. Then all of a sudden you don't have your engineers on board. That's not what they signed up for. So trust goes both ways. And if you don't have trust, basically, if you're that type of person who likes autonomy, who like having a sense of agency, you basically won't be happy in organizations where this trust doesn't exist. I have been working previously in large organizations that work with this traditional IT structure, and you get these developers that are just centered and focused on producing code. They don't really care about the end results that much. It's more important to do the daily task and churn basically the code. What that brings is a lack of sense of ownership. And when you don't have that sense of ownership, it can be very difficult to really get excellent stuff. It's a very different type of process. I personally don't really enjoy that. And as I said, it goes back to the hiring process. It can be very difficult to change culture because the people you hire will naturally gravitate towards that type of organization that you project yourself to be. And if it turns out that you're not basically what you're telling that you are, people aren't happy and the results are going to suffer. It's a little bit of a nebulous answer, but I hope my point came across.
No, it was a good answer. A follow-up question on that. In the context of like a junior developer or a new developer, is it easier or harder for them in your experience to kind of join the team and feel that they are trusted?
It really depends on the team. We have two awesome junior devs. One of them came directly from college. He's amazing. And I think it took him 2-3 months to get really comfortable, but he was pushing code to stuff that we shipped, I mean, the second week. We have one guy who's like super hungry and just wants to be part of everything. And trust can be earned, but I also said that trust is something that is given. So it's like this trust but verify kind of thing. So because we have all of these automated things in place, it's pretty easy to verify that the things that these junior engineers build works or, you know, is up to snuff according to our standards. And of course, you got to have, you know, a decent review process as well, like pull requests and so forth, so that everyone can take a look at the stuff that is being built and being shipped. But having those robust safety nets, like I said, it's a two-way street. So that also builds trust with the engineers rather quickly, that their contributions are valued and that they're making something meaningful that we don't just discard due to their lack of seniority, but actually we can verify it with our fast iterations. So I think, again, it really depends on the team. But if you're able to quickly iterate and you're able to verify the results with high degrees of observability, with high degrees of automation, I think junior devs who come into these autonomous teams quickly earn trust, but also give trust back to the organization and the team.
Okay, yeah, thank you. Great answer, thank you.
Thanks, Albert. Thanks.
Någon som känner sig manad? Är nöjda? Okay. No, I think you covered things very well. So gave
Excellent.
everybody something to think about, I think. How
Great.
to move forward.
Yeah.
Is there anything else you want to add?
Just a huge thanks for giving me the opportunity to talk to you guys, and it's awesome to see you guys being so engaged, and it's a real pleasure and an honor to have this guest lecture for you guys. So thank you so
Great.
much.
Thank you. Then I think we end off with a big applause. Come on. And then
All right.
this session, I think.
Yep.
Yeah.
Thank you.
Thank you. Bye-bye.
Don't forget to share the cool stuff you build. Okay.
Thanks. Hej då.
Bye.
Bye.